Hello, 8th graders. Today you are going to be learning about the rules for naming elements. So if you've ever looked at the periodic table and wondered where did they get these strange names and why do they all sort of sound familiar or similar, well, the goal of this lesson is to be able to explain that. So the ELR is 3.3, and it says that you're going to be able to explain the modern naming rules for elements and their symbols on the periodic table. If you don't already have one, you're going to need one of the papers off of my front counter in order to follow along. The ELR broken up into objectives look like these. The first thing we're going to do is talk about the rules for how to name and symbol an element, and then you're going to make up your own. So you're going to show me what the next possible element could be named using the correct rules in order to do that. Before we get into the naming, let's talk a little bit about review of what we've already done in this class. So you've learned what the difference is between an element and a molecule and an atom. Well, everything in the universe is made out of elements. That's everything off of the periodic table. So if it's on our planet, it's made of elements, which is kind of crazy if you think about it. Just these 100 and some odd different things make up everything you've ever known in your life. A single type of atom is called an element. So if you have a handful of copper atoms, we would call that element. And we learned that before in our pure video. Something made out of more than one kind of element is called a compound. Most things that you're going to see are made out of compounds because it's not that frequent that you see an element by itself. If it helps you at all, I like to think of this kind of like Legos. On the atomic level, if you zoom way in, everything that is a thing, the rocks, the trees, you and me, are all made out of atoms that have been kind of snipped together, kind of like how Legos click together and make bigger things. To give you a sense of how big these things are, think about this. There are more atoms in a teaspoon of ocean water. So think of a little spoon with water in it. There are more atoms in that teaspoon than there are teaspoons in all of the oceans on the planet. That's crazy. So there are a bazillion little atoms in this little teaspoon, way more than teaspoons on the planet. So atoms are pretty tiny. Chemists' jobs are to describe the compounds and predict how they're going to interact with each other. So I plucked off of the internet a picture. We can do this using formula. We're going to learn about formula here in just a little bit, and we can draw it that way. We can also draw it which is called a stick model, which is where we show where the molecules are sticking to each other with each individual atom. And we also use symbols like shapes, like circles and triangles and stuff sometimes, like we've already sort of been practicing. But all of these things are to describe the same thing, how a molecule or a compound looks. In order to read these formula, we have to understand how the naming mechanisms work. That's the goal of this lesson. So first thing we're going to do is start by looking for patterns. I need for you in just a second to pause this video, and on your paper, you're going to jot down some trends that you see. So I want you to look over this list of elements and their names that I've just pulled a few off of the periodic table, and I want you to write down some patterns that you see. Once you're finished, please start the video again after you have like maybe 4 things down on your paper at least. If you're still watching, you have jotted down some trends that you see from this list. Now there are actual rules that go on the right side for how you name or symbol an element. And we're going to start with the symbols. So over on the right side where it says the actual rules, the rules for symboling an element are that all element symbols have to start with a capital letter. So notice that all of the letters up here are all capitals starting with. And if there is a second letter, it has to be lowercase. And you can't have more than 2 letters. So all the elements on the periodic table follow these rules, and sometimes we find or discover new ones, and whenever we do, if they get a new element, they have to follow these rules also. So make sure this is on your actual rules box. So here's why this is really important. If you're sitting there going like, why bother coming up with these rules? Well, take a look at how this compound is written. This compound is called silver selenite, and we write it this way so that we can tell what's in it. If you know that each element can only have 1 capital letter, all that you have to do when you're trying to figure out what's in something is look for how many capitals there are. You don't need to memorize elements off of the periodic table. You can just look and see that there's a single capital A, so there's this thing called Ag. There's also an Se, and there's an O. So we know that this compound has 3 different types of atom in it because we know the rules for how they got named. Let's see what it might look like if we didn't follow the rules. If you made everything capital, you wouldn't know if this was an A or an AG, or you wouldn't know if this was an SEO or what. You couldn't tell how many elements are in this, and then you would have to memorize. Plus, since there are only 26 letters in the alphabet, we can't just give every element its own letter, because there are more elements than there are letters. Now I want you to get a little bit of practice. The next thing on your paper looks like what's on my screen. These are a whole bunch of different compounds. I need for you, somewhere off to the side, to write down how many types of element are in each one of these compounds. And pause the video. When you're ready, come back and check your answers. If you're still watching, you are ready to check your answers. Here are all of the amounts. I need for you to pause this again and make sure that you have the right things. If any of these look different than what's on your paper, call me over in class and I can help you. I'll tell you though that one of the biggest places where people sometimes get a little confused are these L's. This is a CL, not a CI. Notice the font that I chose makes it so the L has a little tail on the top. That's a little different than this capital I right here. It's subtle, but you will start noticing the difference pretty quickly. So this IF has 2, but this HCl has 2 also because this L is lowercase. It's now time to go to the reading. You can either get a copy of this reading off of my front counter if you prefer a paper version, or you can use the reading that I've attached in Google Classroom. They're the same reading. What I need for you to do is you need to go to the reading and now start reading about the names of elements. We've finished symbols, now we're talking about names. On your paper, on the second page, there's a spot for you to jot down the different rules for names that you're going to come across. So there are actually 5 different categories that you can get a name for a chemical in, and one of them is ancient names. So sometimes they've named chemicals after a word that's like a really ancient word that means something that relates to that chemical. There are a bunch of different things on the periodic table that are named for an ancient name. Your job is to find the categories for the others. Answer the questions on your second page of your notes and come back to the video when you're ready. If you're still watching this video, you are ready to check your answers. Here are the other categories. So on the top right of your paper, there's a little box for you to fill these in. I already gave you ancient names. The other categories for how you can name an element are you can name it after a place. You can name it after a myth or a legend. For example, thorium is named after the Greek god Thor. You can name it after people, but they have to be dead. There is only one example of somebody that they broke this rule for, and it's a pretty interesting story. And then the last one is something about the senses. Some elements are actually named after how they taste or how they smell. So we can name them for these 5 categories. Please make sure that they are on the top right corner of your paper before moving on. At the bottom of your page, there are a couple of extra rules. So not only do chemicals have to be named in one of these 5 categories, but they have to make sure that they follow these rules too. Obviously, the name cannot be taken already, otherwise that would be really confusing, so that's the first one. And it has to come from one of the categories, as we said. And this last one is a relatively new rule. So you'll notice that on the periodic table, some things don't end in IUM. But from here on out, as we find new elements, and most of the elements on the periodic table do follow this rule, they have to end in IUM. Please make sure that these 3 are on the bottom of your paper in the 3 boxes. The next place that I need you to go is there is a video that goes really quick, but the person in the video is going to talk through a whole bunch of elements on the periodic table and quickly give you an idea of some of the crazier names on that table. So pause my video, go back into Google Classroom, and open the one that says how elements got their name. Come back when you're finished. The last thing that I need you to do for this video is go to the link that is also in Google Classroom, and I need you to follow along and answer the few questions that are on your paper. You're going to pick out a few elements off of the periodic table and dig in a little bit deeper, and also go and look and see about when things were discovered. The place you're going to go looks like this, and as you are hovering across the periodic table, it'll pull up some information from different elements. You can also grab this slider and slide it across and change the date for when we as a science species knew about certain elements, and you'll see certain things pop up as we discovered them. So pause this video and go find a few on your paper.